All right, this is our semester 2 final review, which covers everything from module 4 to module 8, which are the modules that we've covered this semester. On number 1, this is a parallelogram, and what you have to remember about parallelograms is that opposite angles are congruent. So right here, angle 3 and angle 1 are going to be congruent. So what we do is we set up 2x minus 10 equals x plus 4, and then we're going to solve for x. Now, you're going to solve for x, but you have to make sure you read the directions carefully because it says find angle 3. So after we solve for x, we are going to plug it in, and then we're going to find angle 3. Okay, so we've got x equals 14, and then we're going to plug it in to 2x minus 10 because that's angle 3. So instead of x, I'm going to write 14. And so then we've got 28 minus 10 is 18. So angle 3 is 18. Now don't confuse this with quadrilateral, an inscribed quadrilateral in a circle, which was the most recent module. Okay, that was opposite angles were supplementary. This is opposite angles are congruent. See, there's no circle. It's not in a circle. All right, angle, so angle 3 was 18, and let's look at number 2. So number 2, you have AD, which is median. So our AD is the median, and that means it's cutting it in half. It's in the middle. So this line right here cuts this and this in half. So that means that they're equal. So what we're going to do is we're going to set up 6x plus 12 equals 8x minus 12. Now we are going to solve for x, but you have to pay attention to the directions. The directions say find the length of BC. So BC is the entire bottom side. So that means we're going to solve for x, and we're going to plug in, and then we're going to double it. So let's solve for x first. Okay, so x is 12. That's not my answer though, okay? Because the directions say find length BC. So what I'm going to do is I'm going to plug it into either this or this. It doesn't matter which one because they're equal. So I'm going to plug it into 6x plus 12. So 6 times 12 plus 12. And that's going to be 72 plus 12, which is 84. Now, understand that it's only from here to here. That is 84. Okay, so if that's 84, then this is also 84 because they're equal. And so make sure you don't write 84. Make sure that you read the directions carefully. That's going to be 168. All right, let's look at number 3. So number 3, again, you've got a parallelogram. It's not in a circle. It's not an inscribed quadrilateral. It's a parallelogram. That was a few modules before module 8. And remember that these are going to be supplementary, okay? So we've got 105 plus 15x equals 180. And then we've also got 105 plus y equals 180. Okay, so I'm going to solve for y first just because that one's simpler. So y is 75. You could also just do 75 equals 15x and then find x that way. Oops. Because opposite angles are congruent. Okay, you could do that. Or you could use this. Since they're on the same side, they're going to be supplementary. Either way, you should get x equals 5. Okay, so x equals 5 and y is 75. Okay, and make sure you're careful because this one you could easily pick this one. This one's flipped, okay? This one is x equals 75 and y equals 5. So be careful with your variables. All right, so this one is more of a conceptual question because automatically you might be like, okay, well, 4x minus 10 equals 6x plus 9, okay? But that would be wrong, okay? Now let's look why that's wrong. Altitude means you've got 90 degrees. So SR is an altitude, that means you've got 90 degrees right there, okay? And RST is 4x minus 10. RST, remember that the middle letter will tell you the position of that angle, okay? So that means that this right here, that's RST. So this right here equals 90. Now it is also given that you've got SRT. Now let's look at where that is. SRT would be right here. Okay, does it make any sense that this angle equals that angle? No, it doesn't. Okay, you're just thinking, oh, I have to set up an equation, but this is a concept question, which means this is extra info that you don't need. You have to pay attention to what you're given and then solve. So 4x minus 10 equals 90. We add 10. 4x equals 100. Divide by 4. So x is 25. And read your directions again just to make sure. It says solve for x. So we don't need to plug that in. We just need to solve for x. And there it is. Guaranteed that this right here is probably going to give you one of these other answers. But you have to think about what the question is asking and what angles it's talking about. All right, over here, it's important to know that bisects means to cut in half. Okay, so if CF cuts ECD in half, that means that this right here equals this over here. Okay, and it's okay that it doesn't look like it's equal to, that's fine. So ECF is 4x minus 10. These aren't drawn to scale, so be careful. FCD is going to be negative x plus 100. And those are equal to each other, okay? And I know that because of the word bisects. So we're going to solve for x. For most of these, you're going to have to solve for x no matter what. But pay attention to the directions. The directions say ECF. So we're going to have to plug it back in once we find x. Okay, so we've got x, and we've got to plug it into ECF. Remember, ECF is 4x minus 10. So instead of x, we're going to plug in 22. So we've got 88 minus 10, and that's going to be 78. All right, second one. If you remember, there's a theorem that tells you that these two added will equal the outside angle. But if you don't remember that, that's okay, because what you can do is remember that a line is 180. So if that's 111, then this right here is going to be 69 degrees because 69 plus 111 is 180. And then you can set up your equation. 69 plus 7x plus 5 plus 8x minus 14 equals 180. So you can either do that, or you can also do 8x minus 14 plus 7x plus 5 equals 111. Both of those will give you the correct answer. Both of those should give you x equals 8. Okay, and that's all this is asking, is find the value of x. We don't have to plug it in and find anything else. All right, so this is back to geometry. What is the congruence postulate used to prove ABC is congruent to EDC? Well, you have to remember that these are vertical angles. It's a very common thing that we used in this chapter. And so we've got a side, an angle, and a side. Okay, it doesn't matter if I read it clockwise or if I read it counterclockwise. Look at that triangle. I still get an S, an A, and an S. Okay, and using the same triangle, this says circle all that applies. So you have to circle all correct. Okay, that's what that means. So let's look. We have the two triangles. Does angle D equal angle A? So is this equal to that? No. And that's because it's flipped upside down. That triangle on the top is the same as the bottom, but flipped. So we can cross this one off. Okay, B and D. So B is right here. D is right here. Yes, those are congruent. So I'm going to circle that. And CPCTC means congruent part of congruent triangles are congruent. So it means it's talking about a specific angle that's got to match up, or a specific side that's got to match up. All right, AB and DE. So this right here and this right here, yes, those are in the same spot. That is correct. And BC and CD. So we've got BC's right here and CD's right here. And yes, those are in the same position. Okay, for this, let's go ahead and look at all our angles that are congruent to each other. So they're either going to be congruent or supplementary. So I've got 16 and 13, 12 and 9, 8 and 5, 4 and 2. So all of those purple ones are going to be congruent, which means the other ones that aren't labeled are going to be supplementary to those. Okay, what makes this a little bit confusing is that it says if A is parallel to B. So I'm going to make that really obvious. I'm going to point out A and B. So this one and this one are parallel. And so since we're looking at A and B, and we're looking at angle 16, well, where is angle 16? Angle 16 is in this area right here, in the bottom one. And so that's why we're only looking at these, because angle 16 is right here, okay? If it was talking about, what angles are supplementary to angle 12, then we would look over here because angle 12 is over here. Okay, so angle 16, let's only look at the bottom one because again, angle 16 is in this position right here. So it means that we're looking at this line as the transversal and we can ignore the top one. Okay, so we've got 15 is going to be supplementary because it's a blue one. And then 11 and 12 are at the top, so we're going to ignore these. And 6 is also blue, so we're going to take that one as well. That one is also supplementary. If L is parallel to M, circle all the angles congruent to angle 14. So let's locate angle 14 first. Well, actually, no, let's locate L and M first. So L, M, we're told that those are parallel. And so let's look at where angle 14 is. Well, 14 is right here, okay? So if we're looking at that angle, that means we're only going to be looking at this as a transversal. And we're going to ignore line A. So we're only looking at line B, okay? And we're looking at congruent angles to 14. So 14 is blue, 15 is blue as well. And we've got 10 and 11 are also blue. So I'm going to circle those. And we are not going to look at 3 or 6 because of the position where 14 is. 14 is right here, which means, again, we're looking at this transversal, the transversal line B, not A. We're going to ignore A for now. Okay, and this one's saying if 7 and 1 are congruent, then which lines are parallel? The first thing you need to do is locate 7 and 1. So 7 is right here and 1 is right here, okay? Which means that this is my transversal because those are in the same position. That's why they are congruent. Corresponding angles are congruent. And that means that L and M have to be parallel. Okay, solve for the value of x if L and M are parallel. So if L and M are parallel, that means that these two are same side interior, so they are supplementary. 17x plus 14 plus 4x minus 2 equals 180. We're going to combine like terms, so 21x plus 12 is 180. 21x is 168. Divide both sides by 21, and x is 8. And make sure you read the directions again. It just says solve for the value of x. So we don't have to plug in x to anything. Okay, this one, they're alternate. So this is on this side, that's on that side. Alternate interior angles. These are congruent. So these are not going to be added and set equal to 180. These are going to be equal to each other. And it says solve for the value of x, so we don't have to plug it in. We just have to find x. And we're going to combine like terms. And x is 35. Okay, for this one, you have to pay close attention to the center of dilation. So this is my center of dilation. That means everything touches N and everything shrinks or expands from N. And our scale factor is 1/2. So that means it's going to shrink. And we're looking at the new A, which we would label as A prime. So let's count from N to A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it's 2 to the left. Okay, so it goes down 10, left 2. If I multiply that by 1/2, that's now going to be down 5, left 1. And so remember, my center of dilation is n, so I still want to use that. And I just count down 1, 2, 3, 4, 5, and then left 1. And that right there is A prime. And that is at 3, 3. Okay, right here, don't let this graph trick you. Like this is 2, 4, 6, 8. So that means this is at 0. And this is negative, negative. So this is negative 5, negative 10, negative 15, which means this point is 0, 0. That's my center of dilation. And we've got to find the scale factor, okay? So you're still going to count, pick a point on image A, and then this is the dilated, and you see right there it says A prime. So that means this is the original, and this was enlarged. So that means I can cancel out the fractions. Those are not going to be my answers because it got bigger. So 1, 2, 3, 4, and then up 1. And then to the other one is 4, 5, 6, 7, 8, and up 2. Okay, so that means, you had 4, and then the other one was 8. That's times 2.